Good morning, Cubs. My name's Sam. I'm a beaver leader in First Keyworth. This is my daughter, Lottie. She's a Keyworth Cub. And today we're going to do a really fun and quite delicious thing with you that will, if you've not yet done it, count towards your science badge if you recreate it at home. And I really do think most of you might want to recreate this. It's a nice one. First things first, what's going to happen if Lottie pours some oil into this little glass of water? While she pours, I'd like all of you to have a little think and a guess. What's the oil and water going to do? Oh, enough. Can you see that? Did you get it right? I'd like to think that most of you predicted that the oil is going to sit on top of the water. It's not going to mix, it's not going to float. And there's two reasons why this happens. The first is oil and water don't want to mix anyway. I can put a little bit like oil and vinegar. I can drop some vinegar into here. They don't want to mix. They're just not happy together, and it's because water and vinegar have a slight polarity. They've got an unequal spread of electrons. They're known as polar liquids, and oil is non-polar. A little bit like two positive ends of a magnet. They won't mix. They need to be the same. You need two polar things. If I drop some oil into here, it'll mix very happily with the water. Some vinegar, very happily with the water. It doesn't want to mix with the oil. So they don't want to mix anyway. The second reason, and the reason for the science bit we're doing today, is that they don't have the same density. Density is a measure of how many molecules are packed into a certain space. So in this much water, I might have 100 molecules, and the same amount of oil, I might only have 92. I have 1 gram of mass per milliliter of volume with the water, and only 0.92 grams of mass per milliliter of oil. So it's lighter. They don't want to mix. And being lighter, the unmixed light one sits on the top. That's the two reasons. And the density bit, the difference in how closely together the molecules are packed, are the bits you need to understand for your science badge. Once we know this, about whether they'll mix or not, happily, and whether they'll sit or float, you can do some really nice things with drinks. Here I have some rather lovely orange and mango juice. Would you like some, Lottie? Do you want to pour some?
Yes, please.
Not all the way to the top, please. Just pour it in. A little bit quicker. Bit more. Speed it up. Maybe to about here. Perfect. Then I need something that's either going to sit on top or sit below. You can use a rather lovely fruit syrup, but I was expecting not many of you will have that at home, and with shopping not being quite normal, we can use honey. Now this is already quite runny. If you warm it up, it'll become even runnier. Just pop it in some hot water or in a microwave. I was going to use the microwave, but we're being filmed from the microwave, so I can't. You can make it much runnier, which will make this much easier. So that we can see it, we can colour it any colour you like. I've got a little bit of blue food colour. Need to mix it around to get it coloured. Chopstick. This would be so much better warm, but we'll see how we go. So now we have, never seen blue honey before. Lottie, do you think you are able to pour this in? It's a little bit difficult because it's sticky because I've not warmed it up. But do you want to have a go?
Sure.
At an angle. Have a little prediction. Sit on top, sink to the bottom, mix very happily. I think that's enough. That's enough. You need to wait because it is sticky and thick. Might be better just pouring it in the middle, it'll sink happier than down the glass. There we go. Can you see that? Now the fruit juice has roughly the same density as water. And the honey is about 40% denser, so it's going to sink all the way down to the bottom. And now you've got rather an exotic cocktail. However, one last thing, if I add some ice, Lottie, where's it going to go? Bottom, middle, top?
Top.
Why is it going to go to the top?
Because when you freeze water, the molecules expand. They go in different directions. They don't stay come closer. They go further away from each other.
Yeah. So the water, apart from being polar, it's wonderful, wonderful stuff. It's almost unique in that when you freeze it, instead of becoming more compact, it expands and the molecules are spread further apart. So it loses some density. And there you go. Ice floating on top. So we've got 3 layers in one glass. Would you like to, how would you like to sign off to all the cubs that might be watching? With a big
cheers!
Hope you have lots of fun at home, everyone. I hope you have a really good cub online day. And thanks for watching. Bye bye.